say, a quantum computer running an AGI program. So this quantum computer is a physicist, and it's your friend, and it decides that it's going to do this experiment. And halfway through, when it's looking at the up-down thing, it will sign an affidavit, signed and sealed by a notary public, or whatever, and it will say, I, Mr. Quantum Computer, certify that at this moment I am detecting either up or down. I'm not detecting left to right or both or anything like that. I'm seeing only one of up or down. I'm not going to say which, because if I said which, that would propagate to whoever reads this. But since I'm not saying which, anyone can read it and it won't spoil the experiment. So then, again, instead of the experiment where you put the magnets up the other way, he simply reverses the dynamics of the memory element in his brain, in which he remembers whether it was up or down, but not the one where he remembers that he saw up or down.
Yep.
So then out it comes, out of the quantum computer, into the detection magnet at the end, and it detects that it's sideways. So in other words, what he did not collapse the wave function. And yet...
Right, so the computer has observed whether it's has observed the actual position.
Yes.
Which you might want to think would collapse this wave function.
Yes.
But then what the computer forgets what position it saw the particle in, but doesn't forget that it saw it in one or the other.
Yes.
So something has observed where this particle is, whether it's up or down.
Yes.
It's observed it, and yet when it comes out the other side, it's still, to us, observing the whole system is not up or down.
Yes, in fact, it's certifiably what it was before it went in.
Right, which means that this computer has observed the particle without collapsing the wave function.
Yes, exactly.
Which tells us?
Well, if that happened, that would tell us that the wave function doesn't collapse. If it didn't happen, it would tell us that quantum theory is wrong, and therefore that Everett is wrong.